Good morning. My name is Berjon. I am a freelancer in web standards, and currently I work as part of the W3C team to try to ship HTML5 this year. But today I'm not here to talk about HTML5 because that's boring browser technology. Who cares about that? Seriously. Today I'm talking about distributed extensibility, and the idea is that maybe, just maybe, there might be a chance that after a couple decades of trying, we've finally done it right, or not. But we've done it differently this time. So, extensibility, right? I mean, we talk about it a lot, but when you start asking people what it means, it's sort of like, asking semantic web people what semantics actually means. What's the semantics of semantics? It's not very semantically relevant. Extensibility, people will say, well, it's when you can add stuff. You can extend it. You can, do something more with it. But what does it mean? What does it imply technically? How do I change my technology to make it extensible? How do I know if my technology is extensible or not? And if you start looking through the literature and architectural discussions, etc., you see a lot of X everywhere. Everyone likes to slap X this, XML, X query, blah blah blah. But you see very few people actually discussing what extensibility really means. The discussions that get closest to it is when people start to talk about versioning, because versioning is often about extending something that you have. But there rarely are real discussions of extensibility. And with this, I'm not going to go into architecture, astronautics, or anything, but I think it's worth thinking a little bit about what it means for something to be extensible and to look at the various facets of it. So, extensibility of what? Of what aspect? What is it that you're extending in your language? Well, it could be syntax. So for instance, that's something that might be useful if you have a compact binary format and you want it to be versionable and forward compatible. You want processors of V1 to be able to skip over the parts of V2 that they don't care about. So you want some kind of extensible syntax. In some cases, you might have some kind of macro definition system that allows you to extend the syntax on the fly. And you can get crazy things like ASN1, I think it was the 1984 version, where the macros could redefine the way macros are defined and do so in a way that applied backwards to the stream and to the schema definition and things like that. But even for simple cases, like for instance, CSS has a more or less extensible syntax where you can add new keywords, you can easily add new properties that will be ignored, but that's not really syntax, but you can add new constructs that you can normally hope the parser will recover from. But you can also extend the vocabulary. So going back to the CSS example, when you add a property, you're not changing the syntax, but you're often just adding something new to an existing set. In XML, of course, this is classic. In HTML, this is less usual for now. But the idea is really that keeping the same syntax, you can add more words. Then there's extending the validity. Maybe your language supports adding new constructs, but the new constructs are not valid by default. And so you get flagged by any kind of validator. Maybe it's useful to have a way of extending the validity of your language so that the new constructs that you add are considered valid or well-formed, depending on which type of language, as well as just as much as the native stuff. You can extend meaning, and I'm trying to figure out how that would mean, but I really couldn't. A lot of people talk about the meaning of their vocabularies, but again, the semantics is always very fuzzy. And of course, one thing that's quite interesting is the ability to extend behavior. If you're only extending syntax, but that doesn't change the way that your document renders, or it doesn't change the way that it reacts to interaction, or it doesn't change the way that whatever processor is processing it processes it, then that's, of course, a lot less interesting. You're adding data there, but unless the data can be matched by something that will actually react to it, then you're not really doing that much. So having looked at very quickly at the various aspects of what can be extensible, what does it mean for extensibility of any of those properties to be distributed? Well, the idea is that anyone without coordination would be able to extend things in their own corner. Obviously, any reasonably well-designed language, and that normally includes nothing that I've ever seen, but any roughly well-designed enough language will be extensible, at least by the people in charge of it. Unless you've really shot yourself in the foot, it should be possible. But the idea of distributed extensibility is stronger than that. It's the idea that you make something and someone else can extend it in their corner, and not just extend it inside the walls of their organization, but also ship it back into the world without conflicting with other people for some value of conflicting. And so for every one of those properties, can we make it extensible, can we make it work, and can we make it distributed? Well, in XML, the overall score isn't that bad. The syntax, well, you can't really touch that. The syntax is defined in the spec, and you can't really tell the parser to start understanding new constructs. If you want, I don't know, parentheses to mark a new kind of attribute or something like that, it just won't work. But the vocabulary, of course, I mean, you can't even start using it without having defined one, so that you can obviously extend. Validity, yes, externally through schema, easily. Meaning, whenever we figure out what meaning means, then presumably it's extensible as well through the rest. And however, in terms of behavior, that's considered to be outside the realm of XML itself. It's not part of what XML delivers. HTML, of the old school variety, you cannot really extend the syntax, but at the same time, the HTML parser is quite interesting in that it basically is a function with an infinite domain. So anything you feed it, it will turn into a tree in a way that is entirely predictable. So you can, in theory, extend the syntax, though not through the means provided by the language itself. Vocabulary, the language itself is considered non-extensible, or was. In terms of validity, same thing. Validators have strict rules. There's the glosses about applicable specifications, but basically this is still very centrally controlled. Meaning, again, who knows? And behavior, however, is very much extensible. I mean, the basic HTML runtime comes with scriptability and styling, etc., so that you can actually enhance the behavior through your own creations and by interacting with a tree in ways that you're interested in. This is changing with something called web components that I'll be describing in a moment. Again, in terms of syntax, the same parser stuff applies. And it turns out that now with web components, you can extend the vocabulary. And you can add new elements of your own devising to HTML. Is that done in a distributed extensibility, in a distributed fashion? That's a difficult question. The thing is, well, it's not that difficult, but the thing is, your content will only, your new elements will only operate in pages that they've been imported into willingly. So despite the fact that there's no namespacing mechanism, there is kind of a namespacing by default. You will see clashes if someone tries to import two libraries with the same names, obviously, but that's considered unlikely. Whether that's true or not, I guess time will tell. But so it supports some degree of distributed extensibility, though not that much. But it is definitely extensible. In terms of validity, well, there's a constraint. The HTML specification itself makes a promise that it will never use an element name with a dash in it. And so there's a requirement on web component element names to have a dash in them. So you always know when you see an element with a dash in it that it's not meant to be an HTML element, but it's meant to be an extended element. Currently, validators don't take that into account, and it's still a matter of debate whether they should. But in theory, the mechanism is there so that they could make documents with unknown elements containing dashes valid if obviously the rest of the HTML is valid as well. Semantics, semantics, semantics. I have no idea if that's really extensible, though it is interesting to note that when you create a new element in HTML using web components as a developer, what you can do is give it area roles. Area is basically something that allows an arbitrary element to be mapped onto the accessibility tree. So if you create something that is meant to be, I don't know, a big red button, and you create the big red button element, you can give it an area role of button so that accessibility tools will recognize it as a button even if the user has no way of visually understanding that it's a button. And in terms of behavior, that's absolutely where web components shine the most. They are extremely extensible. Everything basically can be redefined, recreated, reiterated, and so on and so forth. So let's look at an example of HTML done the old way and how web components changes things. So this is a boring old page. And let's imagine that we're in a very interesting universe in which the trendiest thing you could possibly be doing on the web is adding a big red button. Everyone is all the rage about big red buttons, you know, the kind of like really smooth round ones that you feel that you really have to push and, you know, slam into. That's you know, the big red buttons that everyone wants. So, you know, you have your boring old page and you're thinking, hey, I want to be cool too. You know, this whole trendy stuff about big red buttons. I'm gonna add a big red button to my page. And so this is how you would do it today. You would basically start by adding a CSS style sheet because you need some styles defined. But that won't give you a big red button on its own. That might give you the look and feel of a big red button, but it won't give you the behavior of a big red button. And then you need to add a script. And if you're anyone like me, whenever I try to add a component in this way to a page, I normally just add the script, forget the CSS, and then wonder why it all looks like a train wreck, and spend 5 minutes debugging until I realize that I forgot the style sheet. So it's all kind of it's not very well defined. It's all very kind of ad hoc, and you never know if the script is one of those scripts that can actually be placed at the end of the page for performance reasons, or if it's one of those that needs to intervene on the page before it's finished loading, and you have to put it in the head. It's all kind of messy, but that's not even the end of the mess. Then, in order to add a big red button, after you've added the CSS and the script, you sort of add a div which doesn't feel right, and you'll decorate it with an attribute that you made up, a data dash attribute, which you're allowed to use anywhere. Okay, so that turns a div into a big red button, but that's kind of dirty and ugly. You know, what happens if I put two of those attributes on the same element? Do they get turned into big red button and big green button at the same time? I don't know. It's all kind of weird. And that's not even where the problems end. So, of course, it works. You can look at it. Wow, isn't that the coolest page you've seen this year? I mean, you'd like shiny big red button? Yeah, thank you. I knew you'd like it. The thing is, I mean, this is absolutely dead content. If I go in script and I change the attribute to make the size of the button 100 instead of 200, then nothing happens, because I would have to be tracking mutations in the DOM manually in that script for it to work. And that is something that is currently painful. There is a new solution called mutation observers to help doing that, but previously you had to use DOM mutation events, which slow everything down to a crawl and are quite painful to use. And that's just to know, that's just for an element, a new component, to know that its attribute has changed. You know, if I do something like adding directly in the second example, I'm just adding a big red button element on the fly in script to the page, nothing will happen, because the script that has detected big red buttons has already run. So adding anything after page load will not add the button. Again, that script could be monitoring all the DOM changes in the page in order to detect that at some point someone added something like this and then intervene on it and react to it. But that's going to be extremely slow. It's painful for a button. It's code that everyone would have to write, and no one writes, and that's buggy, and that doesn't work in the same way in every browser. And it's way more work than anyone should have to do in order to add a component to a page. So how do we fix this? What's the entry point in terms of the web platform for someone to add an element? So adding this kind of component behavior is something that we've been working on for more than a decade. And in fact, if you go to the XMLPrague archives, you can see me talking about how now, just this year, promise, we're going to have a solution for this. And this is probably 2002, 2003, I forget, 2004. And yeah, it's taken a while. And so what people did is they went back and they looked at how, when we add new elements to the platform, instead of looking at how to extend it, they looked at how, when we add new elements to the platform, things work. And they figured out a way of exposing those mechanisms to third parties, to developers, to anyone who might need that functionality. And the trick is HTML element interface. Inside of a browser context, this is the magic pixie that does everything. It's sort of the force that binds everything together. Anything that has to do with exposing style, exposing ID or class, exposing all sorts of useful core information happens on HTML element. And the idea is that any element in an HTML DOM derives from HTML element. Even unknown elements get a special class called HTML unknown element. And that's how the browser knows how to behave with this, how to put it in the DOM, how to render it, how to have it interact with script, everything. This is really the integration point. So they figured out, hey, if we just expose an API for people to implement their own version of HTML element, then we're good to go. And you start getting things like this. You can add this. Of course, if you come from an XML background, inventing an element is no big deal. It was exciting the first time you did it. Woo! I created my own vocabulary. But it doesn't sound like this big a deal. The important thing is that not only are you inventing a new element, but you're inventing one that can actually integrate directly into the web platform in such a way that it will become usable by script and stylable, etc., as if it were a first-class citizen part of the platform. So basically, this is a mechanism that allows you to create new elements that are first-class citizens, which is sort of, we're starting to get towards that promise of, XML on the web and things that are extensible and that people can start adding and creating the new things and not just have the barrier of browser vendors. And it's really important to understand that this is not something done against browser vendors. Browser vendors are very happy about this, well, at least those that supported it. And the idea is really to take browsers and put them out of the critical path for innovation on the web. Right now, everything has to go through browsers, and everyone, including the vendors themselves, agree that that's a bad idea. It slows things down. And with this kind of extensibility, it becomes possible for anyone to start inventing the new vocabulary and the new syntax and have it work directly as if it were part of the platform. So this is an important approach. And if you take, so one of the big differences is that, so I grab the element from the DOM, and I can do .onClick. I never had to implement onClick myself. The click handling and anything to do with hit testing, anything to do with bubbling the clicks, etc., knowing that it wasn't a click, but it was a tap, but I'm mapping it to a click. That's all handled for me by the browser. Likewise, if you look at the BRB object there, if I set its attribute, it's going to dynamically change the size of the button, And there's a .size accessor that is available on it directly, again, as if it were one of the elements of the platform. So how does that work? Well, the first new thing is the template element. The way the problem was approached was that it was cut down into lots of small pieces that function independently from one another. And the template element is one of those pieces. Basically, it's a way of containing dead content. Any HTML content you have inside of a template is not processed as per the normal rules. It's parsed, it's turned into a DOM, but images are not loaded, scripts are not run, styles are not applied outside of it. Nothing becomes real. It's an inert tree, basically. But this allows you to have content, and basically the implementation, the behind-the-scenes implementation of the big red button is in using a scoped style that does not pollute the rest of the tree, and it's using a simple button with the content element that allows you basically, it's sort of a poor man's apply templates. It allows you to basically insert the tree that from the real DOM into your own template. The way this is applied is through a mechanism called shadow DOMs. Basically, shadow DOMs are secondary DOMs that are sort of behind your own DOM. So when you have a shadow DOM enabled implementation, you have your normal DOM tree. It works the same way as any other DOM tree. But you can add shadow elements attached to any element. So for instance, in my DOM tree, I'm going to have a big red button element, and that's it. But in its shadow, I'm going to add a div and a style element, and the style element styles the div such that it's a big red button. If you navigate the normal DOM, you will never see these elements. They are completely hidden in the shadow. But if you enter into the shadow tree, then you can start manipulating them. One of the advantages of this approach is that it really encapsulates the behavior modifications that your components are making to the tree. It really hides them in the shadows, as it were, behind the elements in the normal DOM. This is part of what makes the normal DOM far easier to use with that kind of component than with the old kind of component where you would have polluted the tree with your own styles and your own elements, etc., and everything would be global together. Another thing is that it composes fairly well. The content element goes back into the light DOM, as it were. So when you have your shadow of the big red button element, you enter into this div that you see here, and when you see the content element, it goes back and applies the content of the big red button. So the big red button, if it has push me as its content, it goes inside that div in terms of the rendering tree, even though the logical DOM tree stays the same. And then, of course, you need some JavaScript, right? Because you're adding behavior. It's not magical. So you need some JavaScript. And how do you actually implement an element? Well, as everything in JavaScript, it has a prototype. And basically, you derive from the HTML element prototype itself. And you add a number of callbacks and a number of behaviors that actually map to how elements behave inside of a browser. So, for instance, this is the callback that gets called when the element is created. You get a created callback, quite naturally. And basically, this allows you to import the template that we saw before, to create a shadow tree behind the element, and to add your template there. That's all you need. And you can set up, afterwards, you can set up additional things, but that's all you need. You've created your own element that behaves with the platform properly. Then this is just an example of how you can simply add your own accessors and make your own element feel more platform-like. So, you know, in HTML, most elements that have attributes, those attributes will be reflected in script. Instead, you don't need to do get attribute this or get attribute that. You can just go .that, and it works. So, for instance, you never need to go to do get attribute ID. You can just do .id and it gives you the ID because the interfaces reflect the attribute. This allows you to do the same thing. You just create an attribute that reflects your own elements attribute, and it will simply work. And finally, in order to react to attributes themselves being set, so if someone calls set attribute, you also get a callback, and you get the value, and you can modify your element accordingly fairly easily. So this is all. This is all you have to implement an element, and even then, I've gone overboard. You could do it in 5 lines, and it would be correct, and it would actually work and integrate with the DOM. But once you've created your prototype, you just register it with the platform, and you're done. Your element has been added with a given name to the list of elements that are supported and understood, and it will be processed as part of the DOM. And really, for the browser, this becomes completely a part of the platform. So how this works afterwards is, as you can see, you just import the component. The component is basically a very simple bundle. So you have the HTML with the template and the script, and you just load that up, and the browser will sort out getting the script and everything else you need from that. And you use the button in the tree, and it will just work. It will just operate very, very simply. I have to say, though, at this point, this is still a moving target. You can make this code kind of work using workarounds and flags in Chrome, but it's still very flimsy. It's still very flimsy because it's an area of fast development. That being said, there's a lot of momentum behind it. I have rarely seen web developers as excited by something new as they are with this, because it really changes the way that you can operate on and create pluggable components. And of course, I've only barely scratched the surface of components. There's a lot more. There are decorators. There are all sorts. There are 5 different specs. But basically, the idea is to explain that with this new approach to the platform, with this new part of the platform, then we really can start extending HTML and start delivering more on the distributed extensibility promise. I have to point out that this is part of a broader movement of the platform called the Extensible Web Manifesto. I invite you to read this. It's a fairly short text, and so a lot of people think that the way that web technology is designed is made not to be extensible. It's meant to be sort of closed and wrapped inside browsers, and you can only touch it through very specific channels, et cetera, et cetera, et cetera. The whole point of the Extensible Web Manifesto is really to break that and to make sure that the standards we deliver make the platform as extensible as possible. And part of that is, so web components is one part. Another part is shipping primitives. A lot of the time, people want to see features. So for instance, you will want to see something that, instead of the ability to add your own big red button, you want to see a big red button directly in the platform. But that doesn't scale. It takes ages for a committee of people to figure out how to do it right, what's the right syntax, getting feedback, agreeing, et cetera, et cetera. The idea is to completely change that and put developers up front and say, okay, go experiment, go create new stuff, go extend the platform. Then we'll see what really works, and we can maybe think about optimizing it in the platform or making sure that it works better here or there. But the idea is really to give primitives. Primitives are, for instance, there's something called service worker being worked on presently that allows you to intercept HTTP requests that the browser makes and react to them yourself. This allows you to change the behavior of a lot of the stack. Or, for instance, we're looking at editing content on the web. It's currently horribly painful. And part of that is because solutions like Content Editable basically have the browser do rich text editing for you. And it never matches the needs of anyone. You can't really do proper structural editing. There are bugs everywhere. Things are pretty horrible. So the idea is that currently we're trying to rethink that in a way that the basic primitive that we're exposing is the ability to have a caret inside your live HTML, move it around, but it wouldn't delete stuff, it wouldn't be able to add elements, etc. It would just provide a hook for the caret to work properly as per platform, and some events for the developers to react to and manipulate the tree. So the whole thing is about making the platform open to people to extend it far more easily. Well, so isn't this supposed to be an XML conference or something? I thought I heard something about that somewhere. And I've been talking about lots of browser HTML kind of stuff for, well, you know, a few dozens of minutes. Okay. So let's talk about XML a bit. How, you know, presently web components have been designed to be used inside HTML. How can we take this and use it with XML? Well, could we have XML components maybe? I don't know, it might be interesting. There are quite a few people out there who have quite a few interesting vocabularies that might make sense in the browser. And when I say make sense, it's not as output of a transform. Sure, that you can already do. You have XSLT, you can transform it to HTML, display it, etc. That's great if your content is static. But what if your content might benefit from being dynamic in a way? Well, of course, you can translate it and inject scripts, and a lot of people are doing this. There's a lot of, notably around XForms, there are quite a few implementations that generate loads of script. But those, while interesting and good, they could be improved by this sort of solution, because it would make it far easier for them to integrate with the platform. So at first, we could have a way of importing things, and oops, I forgot, there's a question mark at the beginning there. This is a processing instruction, of course. So we could easily add a processing instruction that maps link rel import. That's no big deal. And we could, as you saw in the example, we had register element that just registered an element without a namespace and its prototype. We could imagine having a namespaced version of that. Now, of course, I won't lie to you. I doubt that you're ever going to manage to get this past browser vendors, but it would be, given that the mechanism inside browsers is already present for the registration of new third-party elements that are not namespaced, it ought to be reasonably easy to write an extension that would expose the same thing for namespaced content. And of course, this would not make the content work on the broader web where everyone's using it, but for special contexts in which you wish to deliver such things, it would actually be possible to add this and make it work with XML as part of the platform directly. But of course, this, you know, maybe an extension, maybe we could add this, maybe that. That doesn't help today, you know. Well, assuming we have web components, which I think should be relatively mainstream by the end of the year, I hope. In the meantime, how can we process this? Well, we could actually do something slightly dirty, but that actually works. It's fairly easy to write a piece of XSLT that takes every instance of an element that's in a given namespace, drops the namespace on the floor, and renames the element to be whatever dash the name of the element. So for instance, you could easily have a style sheet that converts every XForms element into XForm dash whatever. And this seems like ugly and dirty, but it actually makes it possible to integrate XForms directly into the platform using web components. Once you've done that, you can just, instead of converting to complicated HTML that has to integrate with all sorts of resources, that has horrible scripting problems because it's complicated to generate this right, etc., etc. This actually allows you to ship something that looks like XForms, that smells like XForms, directly into the browser with an XForms implementation in script that makes a lot more sense and will react far better to whatever people might be doing to those XForms in the browser. So I think that this, for the people who are currently shipping XForms as something generated server-side to the browsers, I think it's well worth looking at this as an implementation strategy for the next generation. And of course, it's not just XForms. Any kind of so, for instance, if you look at chemical markup language, you could also transform it in this way, have a component implementing script, and then this would directly in the browser make it manipulatable, scriptable, etc., so that you could live edit CML in the browser. And this applies to basically any kind of vocabulary that you could have. There are downsides to this. It's horribly ugly to write XSLT that turns your prefixes into prefixes, but it actually can work. It's very ad hoc, and when you start mixing vocabularies, you're going to get weird things. But the advantage is you can ship XML today to those platforms, to the web platform, in a way that has not been possible, even though it's been wanted for quite a long time. And so I don't know if this is distributed extensibility done right, to be honest, but it's distributed extensibility done new in a way that actually integrates with the platform. So on the XML side, we've had distributed extensibility through namespaces, and that gives you D for vocabularies, but it stops at vocabularies. Web Components does the other end of the thing. It does D for behavior and for integration into a highly complex execution runtime environment. So it allows you to extend HTML basically. And those two are very different approaches. So it's difficult to say that one of them did it more right than the other. But obviously, it's interesting to look at this new tack. And I would say, of course, from my point of view as a web hacker, that it's more interesting to be able to extend behavior than it is to extend syntax or vocabulary. But of course, I may be slightly biased in that. And with this, thank you very much. I'll take some questions if you have any.
So, any questions? Raise your hands, please.
I see there, Florent. Oh, and up there. No, you're not allowed to ask questions. It'll be something about functions of functions. And,
okay.
I don't understand that stuff.
I have one question concerning the extensibility, and that is
Sorry?
with the extensibility of the HTML. So how would it relate to universal accessibility of web pages when you add the new elements at will?
So the way you handle what's important for accessibility is the accessibility tree. So as I said, when you add a new element like this, obviously it has no immediate meaning to an accessibility tree. It's like a dead element at first. But the advantage of web components is precisely that because you create a shadow DOM behind it with real HTML, then on that real HTML, you're able to use area annotations that might give more meaning to it. But also, if your elements, if your shadow tree elements already have some accessible meaning, then that accessible meaning will transpire to the front element. So it's actually better than, so yeah, that's a very good question. One of the criticisms in the early days of the idea of having XML on the web was that if you don't know the semantics of the elements, then in terms of accessibility, you can't help people. You can't, if the element name doesn't mean anything, and in terms of accessibility, you can't have special behavior that maps outside of the rendering that the developer may have designed. So this actually really helps with that problem because it provides at least the minimal semantics of HTML to back up the elements. So there were questions at the top on, yeah, go ahead.
So one of the other kind of common issues with the idea of having XML on the web was is what the search engines do with that content. Because again, it kind of boils down to not understanding the semantics of the tags, and then how do they know where the links are, and how do they know what content is indexable and what content shouldn't be indexed, and things like that. So do you see any solution to that?
Yeah, actually, so obviously for the old kind, for the kind of search engines we had when we were young and fresh, it wouldn't work, it wouldn't help. But a lot of the crawlers today actually use a browser component in order to show the code. One of the reasons they do that is to avoid spam and cheating, because people would do things where they had pages that were apparently meaningful if you just look at the source, but then they'd have script remove all the meaningful stuff and just put spam instead. So in order to defend against that, they pretty much already have to run a web browser as the crawler. And if you're running a web browser, then it means you can load the components and apply them, and you will actually want to. So it makes arbitrary content indexable again. And yep.
Yeah. First of all, thank you for that talk. Very interesting. It seems like you got it right this time. Well, except for namespaces, of course. My question is, apparently you register the elements on the document object.
Yep.
How does it work? Does that mean that every time you load a page that uses a component or several components, you have to register it again? Or have you thought about how the browsers cache it, or can you register at the level of the browser itself?
No, you can't. So yeah, the registration is deliberately scoped to the document, precisely in part to avoid name clashes, obviously. And so yeah, every time you use this, you need to import the component, and importing the component will call the registration code. Described like this, it sounds complicated, but it's actually very natural. You write the code once, and it will just get called for you every time. So it's fairly straightforward.
But I guess you thought about caching strategies, or?
Well, of course you want to cache your components, but that's a solved problem, essentially. What you do is you do the same thing as you would do with any kind of resources of this kind, so anything JavaScript or CSS. You would long-term cache it. You'd just give like an expiry in 2 years or something, and then you use cache busting on the client side when you need to change it. So yeah, that's fairly well. That's a well-handled problem.
Any other questions?
It's okay. Don't be shy. There's one there.
Oh, thank you. What about the performance of the thing? I mean, if you have a web page which is full of these new kind of HTML elements and all this JavaScript is called to create them, and did you study the performance impact of things like that?
It's too early to have proof of that because the implementations are still immature. But I would be surprised if it became a performance problem. Honestly, JavaScript has become extremely fast. It's a very optimized language by now, and the advantage of this mechanism is that it reuses the same code path that browsers use for the registration of normal elements. So it goes through well-beaten path. And also, I mean, the example I showed was a bit more convoluted than it needed to be. It really doesn't. You really don't need to do that much. So in a normal situation, you won't see JavaScript called that much because I think 95% of the behavior of your element will be handled by the browser already anyway. And just as a last point to add to that, several browsers are currently considering rewriting part of their code from C++ to JavaScript to make it, because it's fast enough. That's not where the bottleneck is. It's not as fast as C++, but that's not where the problems are coming from. And it would make it more hackable to much larger number of people. So yeah, I don't think JavaScript would be a problem. It would be a problem if you had a hugely complicated set of elements, and then you have to load that and parse the JavaScript, etc. On the mobile device, it would be slow. But in general, I don't think it would be a problem. I saw a hand up there.
Sorry, no microphone, no question.
Yeah, we can't hear you without the mics. Sorry.
But there is Q.
Is there a queue? Sorry, I can't see everyone at the same time.
I just wanted to add that performance might even increase from using web workers because elements have only access to scoped style sheets. So the amount of CSS styling and CSS selectors is radically reduced for the elements that you use in HTML templates. So rendering performance can dramatically increase from using web components.
Yeah, that's true. That is true. Rendering should be faster. Well, scope style sheets in general would be faster, yes.
Question there, and then
thank you.
And then 2 questions there.
Okay, yeah, I like the idea, but done right. I think it can be done righter. You were talking about JavaScript, and well, I feel that the abundance of JavaScript is a bit of a pity because it's a procedural language, and now we have XSLT. So why don't you do the same thing in XSLT instead of in JavaScript, or at least provide it as an option?
Well, me personally, I'm not an implementer, so it's not an option I have. I would not know how to use XSLT in this context in order to react to, because it needs to react to events and things like that. But you know, if you can convince people to support XSLT for this, why not? Why not? Personally, I think it's fine to do it in JavaScript, but
well, I can't convince the people, but I thought perhaps you could.
I'm sorry, I think that's a lost battle, but
yes.
Hi, I just had a quick question about the web components. Are they intended to be independent and isolated, or is there some idea about how they can be composable and subclassed and so forth, or is that kind of out of scope at the moment?
There is, it's way too much in scope at the moment. There is a lot of discussion about the exact type of encapsulation that web components should offer. Notably, issues to do with the origin. So if you load a component from another origin, should your scripts be allowed to look inside of it, or vice versa, and things like that? Yeah, that's currently they're more public than anything else. You can go hit inside the shadow tree and toy with it and do things like that. But that might change. It's one of the last details that needs to be settled, and you know, it's a detail. The exact type of encapsulation is not finalized at this point. That said, there is some degree of encapsulation in that the styling can be controlled. So you can, for instance, say whether your component will inherit from the styles of the tree down into the shadow tree or not. And things like that, which is quite cool. And also whether the shadow tree, when you get a content element that goes back into the light tree, if you have styles there, should they inherit down into the light tree and things like that. So yeah, there is some degree of encapsulation settled at that level, but the complete system is not fully designed yet. I think what will happen is someone will ship, and everyone else will have to do the same thing.
We have time for one other question. No question? Okay, good.
There's one from Jim.
Oh, sorry? Not this guy. Okay.
Oh, not Jim.
Yeah, I don't want to retitle this conference JavaScript Prague or something, because it seems to be...
Yeah, I didn't see any mechanisms for components of components and packaging, that kind of thing. Can you give any comment along those lines?
So yeah, there is a mechanism for packaging. So I didn't dig into the full details because it wasn't the main story. But basically, the way there's something called HTML import that's been added to the platform, and it's actually a separate component from, well, a separate part of the component stack, but it can be used with components. And basically what you do is you use link rel import, and you point that to an HTML page. And all the resources in that HTML page get imported into yours with some special magic so that scripts know that they're being part of an import, and they can tell the difference between the document that is their import document and the document that's the importing document. And yeah, so basically you can have packaging at that level. It's not physical packaging, but it allows you to import one thing and get a whole bunch of components at once. Okay.
Thank you.
Thank you very much, everyone.
So before.
Yes.